So Terraform is an open source tool developed by HashiCorp, which allows us to build the infrastructure in a very reliable way, and it helps us to manage that infrastructure in a very easy fashion.
We're here with GDG Cloud London, and again they've organised an amazing talk at Google Campus in London, and they've brought loads of people together, and their community is really inclusive. Don't forget to go to GDG Cloud and join their meetup, follow them on socials, they are a great community. In this video, Pradeep talks about Terraform and modules, specifically on the GCP platform. But these templates can be applied to AWS, Azure and other platforms that Terraform supports. You may be thinking, what is Terraform? Terraform is infrastructure as code. And as I mentioned, it can be used across all the cloud provider platforms. He will begin talking about what is Terraform and modules and give a better explanation than I can. And then he will go on to a demo and actually give you an example of how to use it. Then you also may be thinking, what's so great about this? If infrastructure is treated as code, then you can build any platform you want. But not only that, it can be peer reviewed by your colleagues, just like code is. It can be documented, just like code can be. It can be versioned, just like code can be. You get all the benefits of using, for example, a Git repo of something like GitHub and pull requests. And I think it's really important to get everything versioned. It can then be run on your CI, and it can build your platform on the correct branches, and then it can follow all the same good processes that your code does. Give the video a thumbs up if you enjoyed it, and don't forget to subscribe below if you want to hear more about the latest technologies, open source, getting you the job that you deserve. Hit the bell button if you want to get notified every time I post a video. And coming to hackathons and conferences with me and meetups around the world, and follow me on my really exciting ventures where I meet awesome people just like you.
Today I'm going to talk about the Terraform modules specifically, not the Terraform introduction in detail, and how Terraform modules can help to build the infrastructure on the cloud very quickly. Examples I'm going to take are specific to GCP, but same can be translated to other cloud providers like AWS, Azure, or different providers of Terraform. Quickly about me, so I have about 8 years of experience in the IT industries, worked heavily in the big data, DevOps, cloud like AWS and GCP. Today's agenda is I'm going to a little bit talk about what is Terraform, and then talking about the Terraform modules, and we'll have a quick demo to see how Terraform modules can be leveraged to build infrastructure. So Terraform is an open source tool developed by HashiCorp, which allows us to build the infrastructure in a very reliable way, and it helps us to manage that infrastructure in a very easy fashion. It's similar to like what we do with the Java code or Python. You write a Python code or a Java code, you put on the GitHub, and then you can version it and manage it very easily. Similarly, it allows us to write infrastructure as a code, and then we can manage it similar to what we like how we manage the Python code or a Java code. The official website is terraform.io and has all the documentation. If you are getting started with Terraform and looking for the documentation, I would recommend to use the latest one on the website itself, because they have very frequent release. They generally release like a minor version every 2 weeks or 3 weeks. So if you're looking at some other website or something that might be outdated or for a different version, so it's best to check on the terraform.io or on their GitHub for a specific version documentation. So it has a very simple life cycle. Once you have some Terraform code in a directory, you do Terraform init, which initialize your Terraform code. When I say initialize, which means it downloads all the module dependencies you have on defined in the code, plugins or providers, etc. Once that's done, you run Terraform plan. When you run a Terraform plan, it goes through all the Terraform files and produces an execution plan and gives you a visual output. Okay, it is going to create these many resources and in some fashion, and if there are any syntax error or something, it is going to throw them. Once you're happy with the plan and now you want to execute or basically build something in real, you apply it, and that's Terraform apply. When you run a Terraform apply, it start interacting with the cloud. For instance, Google Cloud, it start interact with a Google API and build the infrastructure for you. Once you no longer needs that infrastructure, then you can just do Terraform destroy, and it is going to destroy all the infrastructure defined in that code. So let's take a simple example, like infrastructure example. Here we have a Google Cloud Platform project. There is one VPC and a subnet, and we want one web server. Application is running. It has some service account attached to manage the IAM permissions. It can interact with storage system, maybe GCS, data store, or any other storage system, and a user connects via internet to the web server. So if you see, it's a small application, but it has a bunch of different the cloud resources you want to create, like you want to create some compute instances, service accounts, storage, and you want to define the policies and everything. If you do with like from a Google console or something, it might be very quick at the start, like when you're doing something, but as you promote that code to, let's say, production, or you want to hand over that thing to someone else, you need to write the extensive documentation, maybe with screenshot or video, something, so that other person can take it if he wants to deploy the similar structure, similar thing in different projects somewhere else, or want to rebuild it. So if we write this in Terraform, then it's just like a bunch of command like Terraform init, plan, apply, that's it. So how does the Terraform code look like for that infrastructure? It's a simple code to define a service account, and it's binding, like I want to have this service account with this role, then I want to have one bucket and some object in it, then maybe a Google Cloud VM instance with a public IP using the latest Debian image, and I want to attach that service account on it. So now with the Terraform, if you put this file in a one directory, run Terraform init plan, it works. It's perfect. But what's the problem with that? Imagine you have many developers or many environment when you're working with that. So you have, let's say, a dev environment, then you want to build the same thing in the test environment, in QA or prod or so on. Or if you have 10 developers and you want to give them separate environment, but similar environment to developer 1, 2, and 3, you copy that code into different directories for different environment or for different developers, which basically creates code duplication, and it's not easy to share that code which you have written. I'll just take an analogy. Let's say if we are writing a Python code or a library, if we write something to interact with, let's say, GCP, Google Storage bucket, and I want to make sure that other person in my team should just interact with the same way. So the other one way is like, okay, I give my code to him and he copies the same Python file and use it. Or other way is like I publish that as a library or a function and he just import that function and use it. So the Terraform module is kind of analog to any function in a Java or a Python language, where you define some infrastructure and then give it to someone, and he just fill those arguments for that function, and he gets the similar infrastructure based on the arguments he has filled. Like if he want different type of machine, he just put like instead of N1 standard 1, N1 standard 2 or something, or change the argument. Terraform module is just a collection of different Terraform resources, like which we saw in previous slides. What it allows, it allows to describe the infrastructure in a easy way, or it gives a blueprint. So for example, this is one blueprint. So if you define the whole thing in one Terraform module and you call that Terraform module, you get the whole infrastructure. So it's kind of a blueprint, and it helps to easily visualize or understand that infrastructure. It allows like reusability of code. I write one module and then other team members can use it. And if that's open source, then open source community can use it. That also allows the collaborative development, which means if I start writing one Terraform modules, other people can also collaborate and we can build that module very fast and different people can use it. Once you have one module ready, it helps you to get started quickly, like if you're doing the same thing again and again. For example, if I write a module to build a Google Cloud network, a VPC with some subnet, once I have that module ready, then if I want to create the similar network in like a 10 different project, I can just quickly do it. But if you do in the from the scratch, it takes the similar time. How we call a module is, it's really simple. You just say module, then the module name, and you define a source where your module code lives. In this code, I just says, okay, my module source code lives in a module directory and then under app. I just pass some arguments like project ID, region or something, and it gives the whole infrastructure which we saw in the architecture. So if you see this code, and it's far better to use that code once you have this in a module, because then once you publish this as a module, consumers can quickly use this code and build the infrastructure. Source can be used as a relative path or a definitive path of your file system, local file system. The source can be on a Git. You can use the version as well, like if you just have some text, you can refer to some particular version. These are some examples. And if you want to repeat the infrastructure, for example, we saw like you want QA or dev1, dev2 environment, you just copy the module again, you change the values. So for example, from this module, I want to create that infrastructure in a GCP project 1, and the similar I want to create in a GCP project 2 with the just label is a different, and rest everything I kept it same, but if you want this to change and these things to be different, you can just pass the relative arguments and you'll get the similar infrastructure with different properties. The module source can be, like we covered, like local path GitHub, but it can be Bitbucket or Terraform Registry, HTTPS URL, S3 bucket, or a GCS bucket. The complete list is here. This might change in future, so it's best to refer the Terraform IO link to get the latest module source. This is the open source Terraform registry, registry.terraform.io, so which has a collection of modules which is published by the provider itself, like Google, AWS, Azure. Then there are modules from the community as well, like people put it, like if I create some module for VPC network or S3 storage or GCS storage, I can put here and people can use it. So if you are like basically starting a POC or something, best thing to do is go to the registry, search for whatever you need it. There are like good chances that that kind of module already exists, so you can just reuse it. And all the modules follow some standards, so it has a good README, like how to use it, what are the input variables you want to pass, and all those stuff. So it just helps you to quickly start. Let's see how we can build the whole infrastructure in an organization based with the modules in a very Lego fashion. So for example, I created one module for a GCP project, then another module for IAM, then another module for BigQuery, so on, like for data store, GCS bucket, GKE, compute, network, or something like that, and many more. Now, now let's go to the Google Cloud Platform. We have some account, and then we want to create one GCP project. Then what we can do is we can just use the GCP project module and create one project for probably one team or one user. Similar fashion, we can create multiple GCP projects using that module, just changing the values of, let's say, project name or something else. Inside a GCP project, I want to create, let's say, one network, then I can leverage the network module. Similarly, I can create one or more modules in the same GCP project or in a different GCP project using the same module. Let's say if I want to have some BigQuery dataset and table, then I can use the BigQuery module. I need some compute instances to host some services. I can use the compute module. If I have some app which is a mix of things, these are like one single resources, but if I have an app, as we saw in the previous diagram, which needs a compute engine, a service account, storage bucket, and so on, then I can just combine all these modules in one Terraform project and I can build that app. So it's kind of, you have some Legos and you can just build different applications once you develop these things. And it becomes very easy to then build resources on the whole GCP. Let's quickly have a demo. For a demo, I just created a simple module to create a GCS bucket. The code is available on the GitHub, which I'll share the link later. So when you have a module, if you look for the open source module as well, it follows some pattern, like it gives you overview which version it is compatible with, what are the input variables, like its meaningful description, if it has some default values, yes or no. And if you don't provide those values to default variables, then it won't override and you will use the default values. For example, when I'm calling this module and if I don't pass any override storage underscore class input variable, it is going to use the standard as a value, which is also good. Like when in an organization, if you want to define resource or an application in a certain way, you can control that using default values or just code in the module itself. Whatever is the required says yes, which means when you call a module, you need to pass those values, otherwise Terraform will fail. And generally it has the usage also, so you can just copy paste this usage and get start, and the output of the resources you can get. This is a Terraform module GCS directory. Here I have a bucket.tf where I've defined a storage bucket which just gives like a name, location, and etc. You can define versioning, yes or no. I have releved whatever the variables I need for this module, and I've defined a bunch of default values. Then once it creates these resources, it is going to output something. If you look on the Terraform registry modules, generally for each modules, you will have example directory where you will have some examples how to use this module, so you can copy it from there as well. So for example, I've created one example which creates a storage bucket without any versioning. If I just see this bucket.tf, I'm using source as which is like 2 level up. I'm passing a bucket name, project ID, that's it. I'm not doing all the other Terraform bits which I've already defined in the module. If I want a storage bucket with a versioning, let's see. So I'm just saying enable versioning, which is a variable in the module, or you can say a parameter in the module. I just say true, and it is going to create a storage bucket which has a versioning enabled. See here, we just have one bucket which is workshop demo. It's nothing to do with this demo. We'll create another bucket which is my storage 3, 4, 5, 6, 7, something like that. So I've just put my project ID, and now what I'm going to do is, let me take my console. Okay, so what I'm going to do is I'm going to do Terraform init first. So it downloads all the dependencies. I think I've already run it, so it doesn't show. So let me just clean up that. Okay, so now once the initialization has been complete, I'll run a Terraform plan. I think I haven't saved this, that's why. Okay, my bad. Let me run the Terraform init again. Looks like it has some issue with the network or something. Let me just change the source to, so I've just changed the source to the local so that I don't have any network problem. So if you see it has downloaded the dependency like the Google provider, it doesn't seem to be a network issue, probably something else. Once I do a Terraform, it is going to show me what it is going to create. Plus green means like it's creating something. So it's creating a resource called bucket, Google storage bucket. The things which says known after apply, which means these values will appear once the resource is created. The name of the bucket which I've supplied is my storage 3, 4, 5, 6, 7. The location, I didn't specify anything when I called the module. Remember, there is a default value as a EU, so it is showing EU. And the storage class also, I haven't defined anything, so it's picking from the module's default value, which is standard. And the versioning is false, again, which I haven't enabled it. So once I do apply and say yes, it is going to create the resource. And now we can go to the console, refresh it, and you have the bucket. So similarly, when you have like a bigger module, which is a complex, or Terraform project which is using multiple modules, you will have all the resources created on the GCP. Now if I don't need this resource, then I can just do, or let's change it to, I want to change the time name from DevOps to Dev. Now if I run like Terraform plan, or let's say Terraform show, it has filled the values. And now if I run Terraform plan again, because I've changed something, so what Terraform is going to do is, it will check the state file and the code and sees that there is some change, that this value has changed to this, so Terraform will try to change this value. And Terraform is intelligent enough to know like is an in-place change or it needs to recreate the resource. If we see here, it just says update in place, which means because GCP allows to update the tags in place, then it won't recreate the bucket, it will just update the tag. I can just do Terraform apply. The tag is, now if we maybe just check the labels, it should have dev. And now if we don't need this whole environment, we can just do destroy. When you run Terraform destroy, it will tell you what it is going to destroy it. So before pressing yes, make sure that you review it, or best practice is to do Terraform, I think it's plan -- destroy, which will give a plan of destroy. So it's, when you actually start with the Terraform, it's safe to do this before destroy, because it will just give you a plan of destroy. And if you are happy, then you can just do destroy. Again, it will give you a plan. And once Sure. Once you press yes, then there is no rollback. Like you won't press Control C or it won't stop. Once it has fired, it's fired. And now, if I go, the bucket is gone. So that's it about the demo. And if you have any questions, I'm happy to take it.
So, do you have an experience with Terraform testing?
Yes. So Terraform, there are ways of testing. For GCP in particular, there is like Terraform Kitchen and Inspect.
Yeah.
I haven't covered because I couldn't cover in this much time, so probably I'll have a separate tag on the Terraform testing in depth.
Because when I was exploring the testing aspect, majority of them were like an integration, means it really creates a resources.
Yeah, you need to create and then that's.
I mean, there were few of them which actually performs a unit test and which will actually just mock it. It won't create a.
But you can't really mock it. So, for example, there are some mocking library, for example, for AWS and those types of stuff. But those libraries can basically live with the real development of the GCP or AWS. The speed they develop, they can't basically run their mocking environment in parallel. So it's best to use Terraform Kitchen or something which will create everything and test it for you.
Okay, thank you.
When you say unit like testing, once you have a module, that's kind of a unit. So once you do a one module testing, that's kind of a unit testing. And once you have an app which is composite of multiple modules, then you can have separate test. But for a module, you can have that test, which is kind of a unit test.
Yeah, I tried with the unit testing, but it was difficult because I didn't knew the language. I think it was Go specific. HashiCorp itself recommends something around the unit testing.
There is that from Grunt. I don't remember. There is one in the Go, but there is GCP which is in Ruby. So it's similar to server spec or RSpec, which is much easy to use it if you're not familiar with the Go.
Okay, thank you.
So if I want to use it and if I want to know what are the limitations and where I should not use specifically for infrastructure build.
Like where you should not use Terraform.
Yeah.
So Terraform is kind of a rapidly developed tool. It is basically maturing enough that nowadays, like I'm using in production for most of the resources. There are maybe some resources, for example, in AWS, there were some resources where there were few other frameworks which were much easy to use for particular service, but for core services and majority of services, Terraform is good enough, I would say. There are like in Google, you have a deployment manager. Again, that comes to a choice of the people also, like which type of language they prefer. They prefer the way Terraform manages infrastructure, which the state, or they want to manage, like they write the deployment manager script in Python or something. But Terraform is kind of very popular in infrastructure as a code these days.
What happens, like, can able to get the current infrastructure state? For example, someone modifies the VM configuration. Mm-hmm. We don't know what changes happened. So we need to go back and try to fix it. It's going to be very difficult. So can I get the previous state of the VM?
Yeah, which is the way what Terraform do is it store all the information in the in the Terraform state file. So for example, here we change the tag value from DevOps to Dev in the code and it changed it. For example, when I create an initial bucket with a DevOps tag, and if someone goes on the console and change it to something else, when I run a Terraform plan, it will say that the current value is, let's say he changed from DevOps to test. The Terraform will say the value is test, but in the code it is defined as DevOps, so it is going to change back to the DevOps. So if someone makes a change outside Terraform, Terraform will going to roll back that change.
So it could be any configuration change. On VM, for example,
on the resource which is created by Terraform.
Like
for example, you create another instance directly on the console, then Terraform doesn't have any control until you import that resource back to the Terraform.
For example, like OS login on VMs.
Sorry?
Do you know about OS login?
Yeah.
Say someone who can able to true to false can able to know what was the previous state using Terraform.
That information is stored in the Terraform state file.
Okay, and how about can we replicate same way for the BigQuery tables? Like I got about hundreds of tables, BigQuery tables. Can able to get those table structure and then replicate from dev to prod?
Like you write, for example, you write a BigQuery table module, and then you just call module for all the tables. You have for one environment, you can have that same for another environment. You can just change the environment name, and you will get in the different environment.
Cool. Thanks.
If the existing Terraform providers don't cover your use cases, how straightforward is it to extend them to your use case?
So, for example, if Terraform provider doesn't support that resource, then you need to write the Go code and contribute back. You can contribute back to have that resource. For example, Google release some new services tomorrow. let's say Cloud Run Fast or something, and that's not there, then yeah, you need to use those APIs, Cloud Run Fast API, and put back into the, contribute back to the Terraform provider, and you can use it. And this is all open source. So for example, new services comes, committers are trying to write as fast as possible. Like Google is also contributing heavily for their provider, AWS is contributing on their provider, plus HashiCorp and other open source guys are contributing it to it. But for example, if there is change in API that's probably not ported into the Terraform, then yeah, you'll see some randomness, and then basically you need to just fix that, and you can contribute that to the community.
Thank you very
guys.
much.